Tonight, on Dark Matter Nap, we are going to confront a truth that crushes our grandest dreams of becoming a galactic species. We grew up on a steady diet of science fiction. We watched starships engage warp drives, rip open the fabric of space-time, and drop into distant alien worlds within seconds. We've been conditioned to believe that traveling to the stars is a simple, linear progression. That just like crossing the Atlantic or flying across continents, interstellar travel is merely a matter of building a bigger rocket, waiting for better technology, and possessing the human will to explore. But when you strip away the cinematic magic and subject our reality to the uncompromising laws of physics, a terrifying architecture reveals itself. The universe does not want us to leave our cradle. The distances separating our solar system from the rest of the cosmos aren't just large. They are conceptually violent. The rules of relativity, the constraints of energy, and the hostile nature of empty space act as a series of heavy, locked doors. Humanity isn't just far away from our stellar neighbors. We are caught in a permanent cosmic quarantine. Tonight, we will break down the absolute physical barriers that keep us locked inside our local system. We will see why our fastest machines are deceptively slow, why the speed of light is a temporal prison, and why the universe is structurally designed to keep us trapped. Before we look at the walls of our cosmic cage, take a second to like this video and subscribe to the channel. It helps this channel reach more curious minds like yours. Now, settle in, turn off the lights, and let's face the deep dark. Let's start with what you think you know about cosmic distance. We look at the night sky and see a crowded ceiling of stars, creating a powerful illusion of proximity. But the scales of space are so massive that human brains completely fail to process them. Consider our nearest stellar neighbor, Alpha Centauri. It sits just over 4.3 light-years away. In a universe that spans 93 billion light-years, 4.3 light-years sounds like a microscopic hop. It's our immediate cosmic backyard. But let's convert that hop into standard mileage. Alpha Centauri is roughly 25 trillion miles away. To understand how brutal this distance is, let's look at Voyager 1. It is the farthest human-made object from Earth, screaming through the interstellar void at an incredible speed of over 38,000 miles per hour. If Voyager 1 were headed directly toward Alpha Centauri, which it isn't, it would take nearly 75,000 years to get there. 75,000 years ago, humans were still living in caves, sharing the planet with Neanderthals. That is the time required for our fastest operational spacecraft just to cross the street to our closest neighbor. The gap between solar systems is a vast, unyielding desert of absolute nothingness. When faced with these impossible timelines, the optimist always says, "We just need to go faster. If we can build a ship that approaches the speed of light, the universe will open up to us." But this is where Albert Einstein's laws of relativity turn from a tool of physics into our ultimate executioner. The speed of light, 186,000 miles per second, is the absolute speed limit of our reality. Nothing with mass can ever reach or exceed it. And as you try to get closer to that speed limit, an incredible mechanic takes over: mass increase. According to relativity, mass and energy are interchangeable. The faster you push an object, the heavier it effectively becomes. By the time a starship reaches 99% the speed of light, its mass approaches infinity. To accelerate it just a fraction of a percent more would require more energy than the entire planet Earth produces in a millennium. Pushing a colony ship to near-light speed requires an impossible, astronomical amount of fuel, hitting a wall of diminishing returns that no advanced engineering can ever bypass. Let's indulge our imagination and assume that we magically solve the energy problem. We discover a limitless power source and build a starship capable of traveling at 90% the speed of light. Now, space itself becomes our greatest physical enemy. Interstellar space is often described as a vacuum, but it is not completely empty. It is filled with a thin haze of hydrogen atoms and microscopic grains of cosmic dust. At our current sluggish space speeds, these particles are completely harmless. But when your ship is traveling at 90% the speed of light, kinetic energy increases with the square of your velocity. At those speeds, colliding with a single stray atom of hydrogen isn't a minor impact. To the ship, that static atom looks like a particle of highly concentrated, lethal cosmic radiation. A microscopic speck of space dust striking your hull at near-light speed would release the kinetic energy of a high-yield explosive blast. At relativistic velocities, the interstellar medium transforms from empty space into a solid wall of pure destructive force, scraping away at any physical material down to its subatomic components. To survive, a ship would need forward shields of impossible thickness, adding wazn and locking us further into the grid. Even if we build indestructible shields to deflect space dust, we cannot bypass the temporal mechanics of relativity, time dilation. Einstein proved that as an object moves faster through space, its movement through time slows down relative to a stationary observer. If you are aboard a ship traveling at near-light speed to a star system 50 light-years away, time for you inside your high-speed bubble slows down dramatically. Your onboard clock might register that only 5 years have passed during the journey. But when you open a communication channel back to Earth, you hit a heartbreaking wall. While 5 years passed for you, a full century, 100 years, has elapsed on Earth. Everyone you ever knew, your family, your friends, and the entire civilization that cheered at your launch has been dead for decades. Interstellar travel is a one-way ticket into the future. You can never go back to the world you left behind. Because the speed of light is also the absolute speed limit of information, communication across these gaps takes decades. If an interstellar colony faces an emergency and broadcasts a cry for help, that signal takes years to reach Earth, and our reply takes years to return. Interstellar travel ensures that any civilization attempting it will instantly fracture into isolated, disconnected ghosts. A unified galactic empire is a mathematical myth. When the brutal realities of high-speed travel become clear, futurists often pivot to the alternative method. We will take the slow journey. We will build generation ships. These are Vishal, self-sustaining flying cities moving through the void at a fraction of a percent of light speed, where generations of humans live, reproduce, and die before their descendants finally arrive at a new planet centuries later. But this introduces a logical trap known as the technology leapfrog effect. Imagine launching a generation ship today that travels at 1% the speed of light. It will take 400 years to reach its destination star. The original crew dies, and their children spend their entire lives locked inside a metal cage for a mission they never chose. Meanwhile, back on Earth, technology continues to advance. 100 years after the first ship launched, scientists discover a breakthrough in propulsion, building a new ship that can travel at 10% the speed of light. This second ship launches a century later, but due to its superior speed, it easily overtakes the original generation ship mid-voyage. When the exhausted descendants of the first ship finally arrive at their destination after 400 years of suffering, they will look down at the planet only to see advanced human cities and a welcoming committee waiting for them. The slow journey is obsolete before it even begins, yet physics forbids the fast journey. Interstellar travel is an obsolete concept not because our engineering is primitive, but because the universe is fundamentally designed for separation. Every solar system is a self-contained island, quarantined by millions of miles of hostile vacuum and unyielding physical laws. It is easy to find this truth deeply unsettling. It feels like we are trapped on a tiny blue dust mote, destined to live out our entire history as a species within the confines of a single solar system. But there is a transcendent beauty in this isolation. The physical walls of our solar system make our presence right here, right now, extraordinarily rare and precious. We live in a vibrant, golden window of time where our planet is stable, our sun is warm, and our atmosphere is thick. We don't need to conquer the stars to belong among them. Sitting on our tiny pale blue dot, trapped by the laws of physics, our minds, our curiosity, and our science have still managed to map and understand the entire cosmic horizon. We have decoded the laws of a universe that we can never physically touch. Thank you for joining me tonight on this deep exploration here on Dark Matter Nap. If this journey into our cosmic cage challenged the way you look at the stars, please take a moment to like this video and subscribe to the channel. Your support helps us continue to create these late-night deep dives into the mysteries of existence. The next time you look up at the night sky, appreciate the stars not as destinations we will someday claim, but as beautiful, distant monuments shining bravely across an uncrossable dark. Sleep well tonight, knowing that our planet is perfectly safe in its cosmic cradle. Good night, and may your dreams reach far beyond the horizon.